Howdy folks, welcome. So in this video, again, I'm just going to go through the practice quiz 1 and again just show you how I go about solving the problems. Again, I recognize it's by no means the only way, and in some cases it might not be the way that makes the most sense to you. So if you have a way that makes more sense, again, as long as you end up with the correct answer at the end, you don't necessarily have to do it the exact same way that I did it. But if you're curious as to where to start, this is kind of how I would start in solving these problems. All right. So again, the quiz is going to be 3 questions dealing with solving equations. So the first question is just kind of your basic linear equation here. So here we're asked to solve the equation for x. So you have 6 times the quantity 3x minus 1 equals 8 minus the quantity 10x minus 14. All right, so again, our first step in solving equations, specifically linear equations here, is we want to simplify on both the left and right-hand side. So what simplifying means is we want to distribute if we can, and we want to add or subtract like terms if that's an option as well. All right. So to start off, looking at the left-hand side here, so we can distribute this 6 through to each of my terms. So again, to distribute means that I'm just multiplying that 6 times each of my terms inside the parentheses here. So when I take 6 times 3x, I end up with 18x. And when I take 6 times negative 1, I end up with minus 6. All right. So now on the right-hand side, we can also distribute this negative sign through to each term. So that's what we're going to do here. So we have 8 just comes along for the ride for right now. And then we have negative times 10x, so that's going to be minus 10x. And then we have negative times a negative 14, so that's going to end up being plus 14. Right, so once you've distributed, then you check to see if you can combine any like terms. So again, like terms are terms that have the same variable raised to the same power. Right, so in this case, on the left-hand side of the equal sign, we don't have any like terms since we have both of our terms have different variables raised to different powers. In this case, right, we have a variable x, and then for the second term, it's just a constant, so there's no variable. However, on the right-hand side, we have 2 constant terms, so we can combine those together just by adding those. So the left-hand side is just going to come along for the ride for right now. So you have 18x minus 6 is equal to, so negative 10x is going to come down. And then we have 8 plus 14, so that's going to be plus 22. All right. So the next step here, so once you've simplified on both the left and right-hand side of your equal sign, the next thing you want to do is you want to get it so you have everything that contains your variable over on one side and all of your constants over on the other side. So to do that, we can use the addition property of equality. All right, so again, what the addition property of equality says is I can add or subtract the same thing on both sides of the equal sign. Again, as long as I'm adding or subtracting the same thing on both sides, I haven't changed the equation at all. All right. So yeah, so in this case, I'm going to go ahead and get everything involved in my variable x over on the left-hand side and everything that doesn't involve an x over on the right. All right, so to do that, I can add a 10x to each side. And then I can add a 6 to each side. So here the negative 6 and the plus 6 will end up canceling out. And here the 10x and the negative 10x will also end up canceling out there. So now I have 18x plus 10x, so that's going to be 28x. And 22 plus 6 is going to be 28. All right. So then to solve for x, once you have everything involves variable over on one side, everything else over on the other side, then you can just divide both sides by the coefficient or the number in front of your variable. So in this case, my coefficient is going to be 28. So I can just divide both sides by 28. And again, as long as I divide the same thing on both sides, I haven't changed my equation at all. All right, so what I end up with is x equals 28 over 28, or simply x equals 1. All right, now again, these problems are really nice because they have a built-in check in there already. So all you need to do is you need to go through and plug in a 1 wherever you see an x in your original equation, and you should end up with a true statement there. All right, so when I do that here, so if I take 6 times 3 times x, which again, x is 1, so we have 6 times 3 times 1, minus 1, I end up with 12 on the left-hand side. And if I do the same thing on the right, so if I have 8 minus 10 times x, which again, in this case, x is 1, minus 14, I end up with 12 as well. So I end up with the same thing on both sides of the equal sign, which means the equation is a true statement, which means that my answer is correct. Oh, there we go. All right, so that's kind of your basic linear equation. So the next problem is dealing with a rational equation. So rational equation is an equation involving rational expressions, with which a rational expression is just a fancy name of talking about a fraction where you have a variable in the denominator. So in this case, I have my variable x in the denominator here. All right. So in order to do this, I'm going to get rid of the denominator. So I'm going to get rid of the fractions. So to do that, I need to find my least common denominator. All right, so to find your least common denominator, you start off, you factor each denominator. In this case, they're already factored for us. So if I have a question like this on the quiz, they'll also be factored for you, just to make it so you have one less step to do, because again, these are kind of time things, and I don't want you guys spending the entire time factoring, when you should be focused on finding the solution for x. Kind of the long and short of it there. All right, so your least common denominator, you start off, you factor each of your denominators in your expression, and then you're going to take the product of each unique factor. All right, so here we have x plus 3, and I have x minus 2 as the next factor here. Then I have x minus 2, but I've already included that, so I don't need to include that twice. Again, it's each unique factor. All right, and then I have x plus 2, so that's a new one. And then here I have x plus 2, but I've already accounted for that. And I also have x plus 3, but I've already accounted for that. So in this case, my least common denominator is going to be the quantity x plus 3 times x minus 2 times x plus 2. All right, so once you have your least common denominator, you're just going to multiply every single one of your terms by that least common denominator. So multiply the second term by that same thing. So you have x plus 3, x minus 2, x plus 2. There you have x minus x plus 3, x minus 2, x plus 2. All right, and then we're going to end up with some cancellation here. So you should always end up with cancellation. So you should never end up with a denominator after this step in any of your terms. So what I'm left with here is 4 times x plus 2 minus 1 times x plus 3 equals 2 times x minus 2. All right, and at this point, we solve this just like we would solve any other linear equation. So again, we start off, we distribute if we can, and combine like terms. So here I have 4x plus 8. Here I have minus x minus 3. And here I have 2x minus 4. All right, and then we can combine like terms here. So here I have 4x and minus x. Here I have plus 8 and minus 3. The right-hand side doesn't have any like terms in this case. So you have 4x minus x is going to be 3x. 8 minus 3 is going to be plus 5 equals 2x minus 4. All right, and again, you want to get everything involving a variable x on one side, everything else over on the other side. So that we can subtract the 2x from each side, subtract the 5 from each side, So you end up with x equals -9. Which again, at this point, if you had a coefficient that is not 1, you divide both sides by the coefficient. But since anything divided by 1 is just going to be itself, that's going to be our answer here. Now again, with these problems, it's especially important to go back and make sure that we don't end up with a 0 at any of our denominators, which if I plug in -9 in for x, I don't end up with zeros in any denominators. I'd have to worry if I had x equals -3, x equals +2, and x equals -2. All right. And again, if you're curious as to whether you have the right answer or not, you can always go back and check by plugging in -9 in for x in your original problem here. So if you have 4 divided by -9 plus 3 times -9 minus 2 minus 1 divided by -9, no, -9 minus 2, -9 plus 2. So that's going to be 1 over 21. All right. And if I take 2 divided by -9 plus 2 times -9 plus 3, I end up with 1 over 21. So again, if you're ever curious as to whether you have the right answer or not, you can always go back and check in the terms of the original problem. All right, so our final question here is dealing with solving the absolute value equation. All right, so your first step in dealing with an absolute value equation is you want to get it so you just have the absolute value all by itself on one side. All right, so in this case, I want to get just this absolute value of x plus 4 all by itself on one side here. So to do that, I can subtract a 3 from each side. So you have -2 times the absolute value of x plus 4. Realize that as I boxed it up, I made it so you can't really see the absolute value sign, but sorry about that. So that equals -6. And then we can divide both sides by -2. So we end up with absolute value of x plus 4 equals -6 over -2, which is going to be +3. All right, so again, the absolute value just means that we ignore the sign. So there are two numbers where the absolute value of those equals 3. So one of those is if we have x plus 4 equaling 3. The absolute value of 3 is going to be 3. The other case is we could have x plus 4 equaling -3. Because the absolute value of -3 means that we just ignore the negative sign. So the absolute value of -3 is also going to be 3. All right. So that's just a matter of solving each of these individual linear equations. So here you can subtract a 4 from each side. Same thing over there. So what we end up with is x equals 3 minus 4, which would be -1, and -3 minus 4, which would be -7. So those are going to be my two answers in this case. And yeah, in this case, my calculator doesn't have an absolute value button. So in this case, you might just have to go through and check just by plugging it in directly here. So when I take -1 plus 4, that's going to be -3 or +3. The absolute value of 3 is going to be 3. 2 times 3 is going to be 6. 3 minus 6 is going to be -3. All right, so that's true. And if I plug in -7 in for x, -7 plus 4 is going to be -3. Absolute value of -3 is going to be +3. So again, 2 times 3 is going to be 6. 3 minus 6 is going to be -3. So that's how you can kind of check your answers there. Yeah, that's it. So again, that's just how I would go about solving the problems. Again, I recognize that by no means the only way, but if you're curious as to where I would start, hopefully you found this a little bit helpful. Have a lovely day, and I'll talk to you all later. Bye now.